Having seen the role that the numerator plays, let's look at the denominator, n plus 1. The first obvious question is why divide by n plus 1 and not n or n minus 1? To answer this question, we will change the binary representation that we've been using to dict paths. This is done pretty easily by replacing the 1's with u's for up and 0's with r's for right, and then creating a dict path based on that instruction list. You can create some dict paths on your own by entering some values of n into the verb path to get a feel for how dict paths work. If you provide a left argument, you can even select specific dict paths. We know that the numerator for the Catalan formula generates every possible path beginning at 0, 0 and ending at nn. But now we have to figure out a way to find the number of those paths that stay above the diagonal, which is equivalent to the left to right rule of having more u's than r's as we move along the string. In 2011, Josef Rukavica came up with an idea to categorize paths by their exceedance, which he defined as the number of vertical edges in the path that are above the diagonal. For all valid Catalan paths, the exceedance is n for a path of 2n, because n verticals in the path are above the diagonal. Rukavica showed that for each Catalan path, there is a unique way to convert a path with exceedance n into a path with exceedance of n minus 1. To do this, the horizontal that first contacts the diagonal is used as a pivot in the path. At the point that its arrow contacts the diagonal, the remainder of the path starts on that diagonal at the point II and ends up at NN. And the point up to the start of that horizontal pivot begins at 0, 0 and ends one vertical space above the diagonal at the point I minus 1, I. This means that if you swap the two paths on either side of the pivot, you begin at 0, 0 and end at a point on the diagonal, followed by a horizontal pivot that starts on the diagonal and crosses one unit to the right, followed by a new second part of the path that picks up from the end of the pivot and proceeds to the point NN. Then the path we've just created will have an exceedance of n minus 1. Each Catalan path with exceedance n will generate a different path with exceedance of n minus 1. The same pivoting technique with the n minus 1 exceedances generates the corresponding group of unique n minus 2 exceedances. This can be done until you run all the way down to n minus n, which would have an exceedance of 0. A 0 exceedance is a path with no verticals above the diagonal. This means that we've categorized all the possible paths from 0, 0 to nn into n plus 1 groups based on their exceedances from 0 to n. We've already found that our numerator generates all the possible paths, so if we want the Catalan paths with exceedance of n, then we just have to divide by n plus 1. And n choose 2 times n, all divided by n plus 1, is the formula that we've come up with to count the number of Catalan strings. Enter Kitty 3, and you'll get the answer 5 as the number of dict paths of length 6 that satisfy the Catalan rules of not dipping below the diagonal of a 3 by 3 matrix. Try some numbers between 10 and 20 and see what you find.